Let's say you're at work tomorrow and someone hands you a welding procedure. They ask you to review it and to make sure the welders are following it. Would you be able to? If not, you will. I'm going to walk you line by line through a real welding procedure and explain what each section means, what it tells the welder, and what an inspector should be looking for. The details at the end of the procedure are just as important as the details at the beginning, so make sure you stick around so you don't miss anything. Let's get into it. Alright, so right here at the top we can see it says Welding Procedure Specification, WPS. So underneath that it says QW482, suggested format for welding procedure specifications. This is just saying that per ASME section 9, this is just a suggested format. So it doesn't have to look exactly like this, but this is a really commonly used format and a really good one to learn from. So right here, company name, we have QC workflow. Our welding procedure specification number, we got GTAWP1. This is basically just a unique number that every procedure should have for tracking purposes. A lot of companies are going to have something different there, but there's always going to be some type of unique numbering system. For date, we have 3/29/26. For revision number, we have a number 1. This date is important. You always want to make sure it's the most up-to-date procedure, because you don't want to be using one that's already been superseded by another one. So right here we have supporting PQR number, and we have a number here. This number is really important. It's a big deal, so let's do a quick 30-second breakdown. The WPS gives you acceptable ranges and tells you how the weld is supposed to be done. The PQR, or Procedure Qualification Record, is the record showing test results proving that the procedure will work. Basically, a weld was made using specific criteria. The weld was tested. Those test results are documented in a PQR. The test results prove that by using that criteria, you can produce a weld that is reliable. Once this is proven, then a welding procedure is developed, giving you the ranges that you can use to make the weld. Bottom line, you can't qualify a welding procedure without a PQR. The WPS is the instruction sheet and the PQR is the evidence backing it up. My next video will be a line-by-line breakdown of a PQR. So here we have Welding Processes. It says GTAW, or gas tungsten arc weld. This tells the inspector and the welder which welding process that this procedure was written for. It has to be followed. That can be the only process that can be used with this procedure. If you try to use a different process, then you're changing an essential variable and a new procedure would have to be qualified. For types, we have manual. That's just telling us that this welding has to be done manually. It can't be done with a machine or automatically. Now moving into joint details. For this procedure, the joint design is a single V groove. For root spacing, it shows an 1/8 inch plus or minus a 1/16 inch. So you want your root spacing to be an 1/8 inch. That's the target measurement, but they give you a little bit of play there, plus and minus a 1/16. For backing, it shows no, so no backing is allowed. And for backing material, it shows no backing, which makes sense. Misalignment not to exceed a 1/16 of an inch. So they are referring to fit up, and that is your tolerance for your high-low whenever you're fitting your pipe. So moving over here to the right, we have our joint detail. This is just reiterating what the text says over here, which can be really helpful than just trying to interpret this from text alone. You can see that it shows a single V groove with your 1/8 inch root spacing plus or minus a 1/16 inch, and it shows a bevel angle of 37.5 degrees plus or minus 2.5 degrees. So if someone asks you, hey, where'd that bevel angle come from? Then you can show them it's right here on the welding procedure. So moving down to base metals. This section basically just tells us what materials and what ranges this procedure is qualified to weld. So this shows that we can weld P number 1, group numbers 1 and 2, to P number 1, group numbers 1 and 2. Under ASME section 9, P numbers group materials with similar welding characteristics. Here's a hint. Check out www.pnumbers.com. It's a browser-based spreadsheet that you can filter, making it easy to figure out what procedures apply to which metals. Specification and type and grade. It shows all P1 Group 1 and 2 to all P1 Group 1 and 2. That means this procedure is written to apply across that range of base metals, not just one grade. Now we are at base metal thickness. For groove welds, it shows 0.0625 inches to 0.688 inches. So this is your range of thicknesses for materials you can weld. So you can't weld anything less than 0.0625 or around a 1/16 of an inch. And you can't weld anything thicker than 0.688, which is about 11/16 of an inch. You have to stay in that range or else you're changing an essential variable and you would have to requalify a new procedure. For things like this, you can use a decimal to fraction conversion chart. I have one that you can download for free. It's my custom QC workflow chart, and there is a link for it in the description or in the pinned comment. Here it shows fillet weld requirements. It says that all fillet to include sockets, laps, and slip-on flanges. All sockets must have 2 passes minimum. Some fillets may be restricted to a 1/2 inch throat per engineering design. And it has a note here that says that all slip-on flanges shall be welded on both sides. Coming back over here by base metal, it shows maximum pass thickness is less than or equal to 3/8 of an inch. So that's saying that in each pass, the welder can't deposit a weld that's thicker than 3/8 of an inch. So now let's take a look at filler metals. This section tells us which consumables are supposed to be used. Specification number, we have 5.18. This is the ASME spec that governs carbon steel filler metal for gas shielded arc welding. For AWS number, it says ER70S2. That is the type of wire that we would need to use when using this procedure. For F number, we have F6, and for A number, we have A1. F number 6 is an ASME Section 9 filler metal weld group. It covers solid wires and rods for GTAW and GMAW filler metals. A1 is the weld metal chemical composition classification. It specifically corresponds to weld metal with carbon steel chemistry. For size of filler metals, we have 332 and 1/8. Those are the size we have to use. Filler metal product form is solid bare, which makes sense because it's GTAW welding. There is no supplemental filler metal. Here it again shows us the range for our thickness for our groove welds, and for fillet welds it says all. That means that any size fillet welds are allowed as long as you're still staying within the limits of this procedure. For electrode flux class, we have none. For flux type, we have NA. Flux trade name, NA. Consumable insert, none. And that's because this is all GTAW welding and we're not using any kind of flux. So this note's pretty important. It says other, no autogenous welding allowed. So that is telling you that you have to use filler metal whenever you make a weld. In GTAW, sometimes you can weld without filler metal. This is just telling you that you cannot do that. If you do that, then you're changing an essential variable and you would need to qualify a new procedure that allowed autogenous welding. So moving on to page 2. If you're still with me, do me a favor, hit the like button, subscribe. It'll help me out and it'll help these videos keep reaching you. And hopefully you're getting some help out of them. So here we go, moving into welding positions. Positions of groove, it shows all. So in groove welding, you can weld in any position, 1G, 2G, 6G, it doesn't matter. Welding progression, it shows up, yes, down, no. So you cannot weld downhill, you can only weld uphill. Positions of fillet weld, you can weld in any position. And now moving to preheat. Preheat temperature, it shows our minimum is 50 degrees. For our inner pass temperature, the maximum is 450 degrees. So that's pretty straightforward, but underneath it has a note that says Thicknesses over 1 inch shall be preheated to 200 degrees Fahrenheit. 2 inches of each side of that weld shall be dry before welding. So even though your preheat minimum shows 50 degrees right here, this added note gives an extra requirement for thicker materials. So you got to make sure you pay attention to that. Moving over here to the right side, we have post-weld heat treatment. For temperature range, it shows NA. There's no time range. So it's basically telling us that post-weld heat treat is not required using this procedure. It does show other, and it has no forced air cooling permitted. So even though there is no post-weld heat treat, there is still a cooling requirement that you have to pay attention to. Moving on to shielding gas, it shows that we should be using argon with a 99.995% purity or mixture at a 20 to 35 cubic feet per hour flow rate. It shows no trailing gas and no backing gas. This section matters a lot because changing your gas type or your purity or your flow outside of this range is an essential variable. And what does that mean? Qualifying a new procedure. Now you're getting it. Now moving over to electrical characteristics. This section gives you your welding parameters. So it gives you 3 different sets of parameters. All 3 processes are GTAW. All 3 classifications are 70S2 welding wire. 2 of the processes calls for 332 for diameter, and your third process down here allows 332 and 1/8. For current type and polarity, they're all 3 DCSP, which stands for direct current straight polarity. For your amps, the first 2 show 80 to 120, and your bottom process here shows 95 to 135, so you can crank up the amps a little bit on that one. They all 3 call for manual wire feed speeds, so we're hand feeding, so manually. They're all 3 electric for their power range. For voltage, this top 2 call 9 to 12. This bottom one calls 9 to 15, so it has a little bit higher of a max. And for your travel speed, all 3 are different. So that's what separates these top 2 processes. So it shows that the top one should be 3 to 6 inches per minute. The next one should be 4 to 6 inches per minute, and down here it shows 6 to 9 inches per minute. So when someone says that the welding procedure gives you your welding parameters, this is what they're referring to. This is the electrical characteristics. This tells you how to set your machine and tells you everything you need to know as far as your amps and your voltage and your travel speed and all those things. For pulsing current, we have none. For our tungsten electrode size and type, we can either use a 332 or 1/8 tungsten. And it shows to use EWTH-2. That stands for 2% thoriated. Mode of metal transfer for GMAW, FCAW, this is NA because we are using GTAW. And moving into technique. There's a lot of useful information that gets buried here because it's at the back end of the welding procedure, but this is really important information also. For string or weave bead, it shows you can run a string or a weave, but if you weave, it is not to exceed 4 times the core diameter. So if you were using an 1/8 inch wire, you would multiply 1/8 inch by 4, and you would not be able to create a weave that is wider than a 1/2 inch. For our gas cup size, we can use anywhere from a number 4 to a number 6. Initial and inner pass cleaning, it says that we can power brush and grind and use hand tools as needed. Method of back gouging, it says when necessary, use carbon air arc and mechanically grind or chip. So if you have to back gouge, you have to use carbon air cutting or do it mechanically. Oscillation, none. Contact tube to work distance, it's NA because we're using GTAW. Multiple or single passes per side, you can use multiple passes. For multiple or single electrodes, we are using a single electrode. no electrode spacing, no peening. And down here at the bottom, we have just a few more notes. It basically says that all welding materials shall meet the country of origin requirements. Filler metals should have MTRs. There should be sufficient wind breaks during welding. And when a bevel is formed by oxy-fuel or plasma arc, you must remove a 1/16 of the bevel face. So here's the big takeaway. Don't just glance at the welding procedure and move on. You want to check the process, the filler metal, joint design, material group, thickness range, preheat, shielding gas, parameters, and always read the notes. A lot of issues happen because somebody only looked at the top half of the procedure and missed a restriction that was buried lower down. Once you understand how to read a procedure, they become a whole lot less intimidating, and all it is a roadmap for how that weld is supposed to be made. I'll be doing a step-by-step breakdown of a PQR next. If you stuck around with me to the end, thank you. I hope this helped you in some way. Give me a like, hit that subscribe button, and I'll see you soon.